All right, 7.3, power functions and function operations. Sounds like all sorts of interesting stuff here. Basically, we're going to do some basic substitution here, and then we're just going to figure out if there's any restrictions on my x values. So, for example, I have two functions, f of x and g of x. My f of x is 2x. My g of x is x plus 1. So you're going to have two expressions to work with. If I'm doing addition, okay, f of x is 2x. G of x is x plus 1. Now, even if I were to put parentheses around that, which I'm going to encourage you to do, and you'll see why when we get into the multiplying part and dividing part, there's still nothing really to distribute here. It's just plus. So, I'm just going to go ahead and I'm going to combine my like terms. And this would be my f of x plus g of x. Okay? Just combining the like terms. Domain I'll be back to in a minute. We're going to run all the domains at once so you can kind of see how the pattern develops itself. But on any of these, the only thing you really have to be cautious of is making sure you're taking things in the right order. Okay, so f of x minus g of x. Same two things. The only difference is going to be now I'm subtracting. And this is where the parentheses are critical. Because if I don't put the parentheses in, yeah, I'd get the minus x part, but I'm subtracting this entire quantity. In other words, that negative distributes to both of those. So when I go to rewrite it, negative x, negative 1. So anytime you're plugging these in and you've got a term that has more than one piece to it, here, you're going to want to use the parentheses and then combine. 2x take 1 away is 1x minus the 1. And again, there is a difference when you're doing this between like f of x minus g of x or g of x minus f of x. You have to watch. This, I don't know where that function symbol came from. It should be a times dot. Multiplication, same thing. F of x times my g of x in parentheses. And I'm just going to distribute. Anytime you see anything with a plus or minus in between, if it has multiple terms, a multiplication dot. I have no idea where that comes from. But here, anytime I see anything with plus or minus or something, I'm always going to put parentheses around. In a situation where I either subtract or I multiply, it's going to be important that I know this 2x doesn't just times to the x, but it also multiplies to 1. Now sometimes, and this is going to be the one probably when we do a quiz on this that will get somebody. I hope not. F of x over g of x. So here's the question of the day. The fraction, can I wipe those x's out? I know, but that's going to be dependent on if somebody put something on the thing before. This isn't a calculator. Yeah. Can I cancel the x's? Okay, for whoever said no, why not? Okay, here, for me to be able to cancel the x's, I'd have to be able to take an x out of all three terms here, and this term doesn't have an x. The only way I could cancel something in parentheses like this is if I had another x plus 1 up in the numerator. So this is actually done already. So when you're doing division, you've got to be careful. If it's just multiplying, I can cancel. But that plus or minus bond is strong. The only way I can break it is to have something identical going along with it. You've got to be careful there. So here comes this whole domain thing. Domain is basically, are there any restricted x values? And by restricted, I mean is there any value I could plug in for x where I couldn't get an answer on the calculator? So if I plugged in this value for x, is it going to say error and not tell me anything? Most of the time, no. Restricted. So for instance, here, I can plug in 0, I can plug in any positive or any negative number I want, and the calculator is going to give me an answer. So my domain here would be all reals. I can plug any number I want in, I'm going to get an answer out. If I take some x value and subtract 1, no matter what number I can plug into the calculator, I'm going to get an answer out. Like, sweet, this is going to be one of those like the domain before where it's negative infinity to infinity on everything. Not quite, but close. Here, I can plug in any value I want for x and square it, and then add 2x. Okay. You're like, Hardy, they're all deals. What are you doing? But then, the last one. When you're dividing, what number can't we divide by? 0. So, I need to figure out, since I can't divide by 0, that would be a problem. What number would cause me, if I plugged in for x, to divide by 0? -1. Because what I do in a situation like this, where I've got a variable in the denominator, I'm going to do a quick little equation with this. I'm going to set my denominator not equal to 0. And solve it like I would a regular equation. I'll subtract the 1 over. X cannot be -1. If I plug that in, -1 plus 1 is 0. So my domain is all reals not equal to the one number that would cause me a problem. And that's how the domain works when we get into this. We're only putting in things that restrict. And the only number out of all of these problems so far that gives me a problem is -1 here, because it causes the denominator to be 0. Okay? So that's one of my times that it's going to come up. There's one more coming still, but for the most part, it's going to be all reals. The biggest thing as you go through these is going to be your attention to detail. I know I say that a lot in here, but it's true. So like for instance here, I got an f of x and a g of x, and I basically, okay, add them up. Okay. I don't even really need to put the plus in here, but why not? Can I do anything to these? Will this be like -4x to the 5th? Is it? Is it? Is it? No. Okay. Silly person. Because again, when I'm adding and subtracting, I have to have the same base and exponent to be able to add them up. If that's the case here, okay. Add them up. I'm done. Sometimes you may not be able to do anything else. Sometimes there'll be, because that's not true. That was me being silly. Because I definitely cannot add the exponents when I'm adding. That only happens when we're multiplying, but we'll get to one like that. Here, if I have f of x minus g of x, here's one of those detail situations some of you speed right over. What happens when you minus a negative? Okay. So I've got to make sure that I write it that way, with a plus in the middle. On a quiz, I wouldn't want to see minus and negative. Well, no, we know how to minus and negative. We know it's plus. So simplify it. Okay? Doesn't matter if I switch the order around. Yeah. Okay. G of x plus f of x. I still can't put anything together. But again, it's one of those detail issues. Are you watching to see what's going on? Oh my. G of x minus f of x. No pluses or minuses to simplify. Still can't combine them anymore, so that's as far as I can go. Now, I'm not going to force you through the agony of every single one of these, but there's a few certain ones that I want to make sure that we hit. Just to make sure, again, we're paying attention. Notice when I get to number 2, okay, I see a plus. I'm going to immediately put the parentheses around it. Because then, when I get to a problem like f, I go, okay, f of x minus g of x. Again, this is where the parentheses are so important. That negative not only goes to the x, which it would have, even if I didn't put parentheses there, it also goes to the 3. So I've got to make sure that my signs get changed on both of those. And again, don't just leave it. Find your like term. And it's the same thing with h. Just because my g of x is first minus my f of x. But here, I've got minus a negative, which is going to become plus. So we're back to kind of doing Algebra 1 pre-algebra type combining like terms. We're just doing it kind of in a different format. X and 2x is 3x plus 3. But some of you really got to be cautious. Watch the symbols in between. There's a difference here. We've just been adding and subtracting through these first 2 examples. When we start to multiply and divide, that's going to cause us a little bit different of an issue. Because as we continue to work our way down, number 3, we get to our first multiply. So we're f of x times g of x. So here's our first new question. When I'm multiplying with variables of like bases, they both have x, so they're like bases, what do you do to the exponents? Okay, so when we get here, we need to add the exponents. Now, adding the exponents does not mean I go to a decimal. I do not do 1, my 1 here, plus 1 1/4 and call it 1.25. I don't call it 1 1/4. There's nothing that's going to need to be rounded, because when I add 1 plus 1/4, I'm going to get a common denominator, so I don't do anything silly. My common denominator, since I only see a 4, is 4. Rough question of the day? How many 4s are there in, how many fourths are there in 1? 4, because 4 divided by 4 is 1. Anytime I have 1, it's just that number over itself. 4 plus 1 gives me 3x 5 fourths. That would work in this case. It depends. Because in this case, that absolutely works. But now here's my issue. The domain. Let me just rewrite this for a second. I'm going to write it in its radical form, just so you can see something. Remember, it's exponent over root. So it would look like this. And here's why I'm writing it this way. Anytime that you get an even root, so if it's square root, fourth root, sixth root, if it's an even number, that would cause a problem. Because if I tried to take a negative number, okay, let's say, for instance, I said, okay, what can I take to the 5/4 power? Let's see. What if I tried to do, I don't know, negative 4? Whoa, what's this? Negative 4 to the 5/4 power. Uh-oh. Non-real answer. What? Let's go to that. Anytime you have an even root, you can't have a negative. You can't take the square root of a negative. Now, I know we can pull an I out. But as far as real numbers go, answers I can get on the calculator, I get an error message like I just did. So whenever you get something like this, x has to be greater than or equal to 0. In other words, it's 0 or positive. I can take a root of 0. Okay? I can take a fourth root of a positive number, but not this. So, even roots, not negative. The only two exceptions that you will ever have to your domain not being all reals, we've done them both. If you have a radical or an exponential term that has a root that's an even, it'll be x is greater than or equal to 0. Or if you have a fraction with x in the denominator, set that equal to 0, and that'll be what you have. I don't have anything, so call yourself an exterminator. That'll work. So, that's what we're going to do on situations like this. If I'm dividing, yes, ma'am. Oh, when I plugged in that example before, I was just trying to show a general example of, let's say I tried plugging in a negative number for x, what would happen? Because that would happen, let me bring that back up. Right, what I'm trying to show here in general, because I can't, of course, show every single opportunity, but if I were to take a positive number, again, it said I can't do that. If I took a positive number, and again, I'm just picking a number at random, and I did the same thing to the 5/4, I can get an answer out. So what I was just trying to show you with a numeric example is, as long as I put 0 or a positive number in for x, I'm going to be okay. But if I end up putting in a negative number here and try to do it, when it gives me that error message, that's telling me that can't be part of my domain. So I can't have any negative numbers in when it's the square root like that. And it's going to be the same even when we're doing division. Alpha of x divided by g of x. What do we do with exponents when we're dividing? Right, we're going to subtract. So again, I want a common denominator, so I'm going to turn that x to the first into 4/4. And I'm going to end up with 3x 4/4 minus 1/4 is 3/4. And again, I look at this and go, uh-oh. It's an even root again. So what's my domain going to be? X has to be greater than or equal to 0. Okay? Anytime you get an even root, if this is a 2, a 4, a 6, an 8, whatever, that's automatically going to put you into your domain having to be greater than 0. Because if it's not, you're going to get an error message on your calculator. Yep, we're just subtracting the 4 minus the 1 to be able to get my 3/4 on that one. But again, those are the only two things. So you're like, a lot of these come up when it's multiply and divide. Yes, that's absolutely true. So here, as we do a couple more with the multiply and divide, this is kind of like the multiplication example at the top. I'm going to distribute. Okay, so that I've got simplified. Do I have a fraction? No. Do I have any even-rooted radicals? Now, some of you are saying 2 is an even. Okay, here's the difference. For it to be a root, remember, the root would be in a denominator. This would have to be fractional for me to get it into like a square root type situation. This is just plain old x squared. I can square any number. I can square a negative. I can square a positive. I can square a 0. It doesn't matter. We don't have any restrictions. In fact, all reals. However, when I do f of x over g of x, I could run into one problem. Where's the one problem going to be? I can't divide by 0. So again, I'm going to take what's in the denominator, set it not equal to 0, and solve it. And I'm like, ooh, okay, so negative 3 would be a problem. Negative 3 plus 3 would be 0. So all reals not equal to negative 3. Again, it's just those two things, fractions and fractional exponents. So that kind of goes together. You see a fraction in there, you have an issue, okay? Now, what will come to become as favorite to some of you is factoring, composition of functions. Let me explain how this works. Okay. When you see a function inside of a function, here's how it's spoken. This is called, like for instance here, this is f of g of x. So, here's how this works. We're going to do a little bit of double substituting. So, for instance, we always, kind of move this down a little, we're always going to start on the inside. In other words, here we're going to start with the g of x on letter A. And here's how it works. I'm going to take this g of x, and I'm going to substitute its actual value, 2x minus 1 in. So here's what it'll look like for our first step. G of x gets replaced with its value, inside out, all the time. Once I get here, I'm going to substitute again. This time, I'm using the f function, so I'm using the 3x. But when I get to the x part, you'll never guess what I'm going to plug in for it. Two x minus 1. So you're like, now wait a minute. You're like, Hardy, now you're just going a little too far. How the heck did you do that? How's this work? Let me try doing it a little bit off here to the side so you can see how this works. I guess I'll ask this first. Are we okay seeing how this turned from f of g of x into f of 2x minus 1? If we're lost there, we got a whole different issue. Okay? So to get from here to here, let's think about it for a minute. When I have f of x equals 3x, basically what I'm telling you is, whatever's in the parentheses is what goes in where x is at. So when I have f of 2x minus 1, when I go to fill this out, to be consistent, if what's in the parentheses is what goes here, well, this is what's in the parentheses. That's what has to go into that spot. It's straight up substitution is all you're doing. And then just simplifying it, of course. And it goes the same way no matter what. Here, I'm starting with f of x on the inside. So I have g of, what's f of x? 3x. So you replace the f of x with its value. That's my first step. Then, g of x is 2x minus 1. But for x, it's whatever's in the parentheses. There's my x replacement, but everything else stays the same. Oh, geez. Holy moly. Even if I'd have said, 2, at least that'd have been 3 minus 1. That'd have made a little mathematical sense, right? Geez. You guys are going to be able to put together an entire tape of Hardy bloopers by the end of the year here. And you're like, here, look at this. Oh my gosh. Just don't show it to anybody. It's doing my eBay. So now, to simplify this one, or maybe I was just thinking ahead. I don't know. 2 times 3 is 6x. Do I distribute the 2 to the 1? No. That's why the parentheses, again, become important. You're only going to multiply to where you see the parentheses. I didn't do anything screwy this time. Good. You're like, all right, maybe. Yes, you can plug a function into itself. So this would be f of x. Yes. And this can kind of start to look weird. So you're like, okay, I'm plugging into f, which again is 3x. So 3, but x is whatever's in the parentheses. So basically, it's just time and time again seeing what's inside, putting that in the parentheses first, and then going back and saying, okay, so my g function is here, it's 2x, but oh yeah, x is the parentheses. And that can be something that's tricky, especially here when you might want to forget about writing the -1, because this is only replacing x. So you've just got to keep reminding yourself, you need to do things right. You're only doing 1. Distribute that through, make sure I'm not doing anything screwy again. And if I was doing domain on all of these, they'd all be negative infinity to infinity. Oh, geez, all real. That's probably being heard real well on there, too. Actually, all reals and negative infinity to infinity do the same thing. But, again, that's what we put if we were trying to find the domain. So, just kind of as a mini self-quiz, as we come down here, let's take a look at 9 before we look at the doozies on the bottom. F of x divided by d of x. First question, can I simplify it all? No. Not unless all 3 of these have something in common. Okay, do I have any restrictions for my domain? Or is it just all real? If not all reals, how do I find out what the restriction is? Right. I can't have my denominator equaling 0. So here it's all reals except 3, because that would cause my denominator to be 0, which is a big no-no. The only other things I'm going to mention down here at the bottom. I'm going to take a look at 12 and my second 13, which should be 15. This is just bloopers are us. It should be like April Fool's Day instead of whatever day it is. I have no idea. I'm waiting for the roof to crash in. F times g of 5 is actually just f of 5 times g of 5. So what I'm going to do is I'm literally going to just plug that number in for each of my functions. So here, for instance, f of 5 is just going to be 3 times x is what's in the parentheses, plus 2. I'm just going to kind of bracket that off here. My g of 5 is my g function, but again, 5 is going to replace the x. So 5 times 5 minus 4. So we're actually going to get a numeric answer. We're not going to get some notation here. So 15 plus 2 is 17. 25 minus 4 is 21. Afraid to trust myself, but I'm going to. And get my answer, and just go that route. So again, we're just multiplying the two things together. I could have FOILed this out and then plugged the 5 in, but I really think that was more work than it's worth. So finally, one more composition of functions here. F of g of x. So this is going to be f of, and then my g of x, 5x minus 4. So when I go to plug it in, this is going to be interesting. We have the absolute value of 2x, but again, x is what's in the parentheses, minus 1. Distribute through. So 10x minus 8 minus 1. Absolute value? Yeah, absolute value. It's just part of my original functions. You mean what homework check will this be on? It'll be due whenever the next homework check is, which will probably be somewhere towards the end of next week. Correct. Yes, ma'am. Like here? Okay. So when I'm here, are you good with how I went from g of x and just basically put that where the parentheses are? Okay. So f is telling me I'm using this function, this 2 times x minus 1, but the absolute value of it. So I'm just rewriting here 2x minus 1, but instead of using the x that's right here, I'm replacing the x with what's in the parentheses. I'm replacing the x with the 5x minus 4, with my g of x. Then I'm just going to distribute my 2 through. So 2 times 5 is 10x. 2 times negative 4 is negative 8. And then I'm just combining like terms. Maybe. Okay. So 12, the difference back here is f of 5. So again, my function at x is 3 times x plus 2. But whatever's in the parentheses is going to replace x. So 3 times 5 plus 2. Or over here, my 5 here, since it's g, is going to replace this x. So 5 times 5 minus 4. It's just lots of f's and g's and variables and numbers. Yeah, it's one of those you've really got to take your time on. Because otherwise, as I showed perfectly as a good example myself, you can mess it up.